We want to find this function in both of these forms, so let's start with it as a cosine. Well, the first thing I spotted will apply to both sine and cosine. The mean position appears to be here, and we can see it goes up by 2 units from the mean position and down 2 units from the mean position. So the mean position will always be so that this is plus 2 and minus 2 or whatever the stretch is. So it's going to be the same above and the same below. So immediately we have found that A is equal to 2 because that's the vertical dilation, and that D is equal to 1 because that's the shift. And that will apply as well when we come to do part 2 with the sine. So A is equal to 2 and D equals 1 here as well. Now, looking at the scale, this must be pi by 3, and this would be 5 pi by 3. It seems that every 2 squares is pi by 3. So if we look at these two equivalent points, that gives us one complete oscillation in here. And that's happening at 5 pi by 3, take away pi by 3, so that's 4 pi by 3 for the period. Now we know that the standard sine and the standard cosine both have a period of 2 pi. So if B is here, we know that the scale factor for the horizontal dilation is 1 over B. So 1 over B times the original 2 pi must be equal to 4 pi by 3. We can cancel a pi from here. So 2 over B is equal to 4 over 3. That means that B over 2 is equal to 3/4, and that means that B is going to be 3 over 2, and therefore the scale factor is 2/3. Once again, that applies in both parts of the question. So where they're going to differ is in the C. So, well, if we look at this, it seems that because D is 1, let's look at part 2 first actually here. This part is 0. Now that means that for the sine, which normally has its 0 here, that it hasn't moved either left or right. It starts there and it goes upwards first. And that's exactly what this does. So I'm going to suggest that C is equal to 0 for this one. With this one, it's this point here, which is normally at Y. So this one has moved to the right by pi by 3. So x minus pi by 3 will do that, so I'm going to suggest that C is pi by 3. So for part 1, that gives us y is equal to 2 cos 3 over 2 x minus pi by 3 plus 1. And for part 2, it's going to be y is equal to 2 sine 3 over 2x, there's no c, plus 1. And we're going to plot these and see how well we've done. So let's bring in the calculator again. We need to be back to radians. Don't worry about what's happened to the graph here, we need to adjust a few things. So let's start with this cosine. So I've got 2 cos, then we're going to have 3 over 2, open another bracket, x take away pi on 3, two close brackets, plus 1. And let's graph that. It's going to look rubbish to start with because we're still set up for degrees from the last question that we did. So let's go, as this does, from 0 to 5 pi by 3. And the graduations here are in pi by 6s, so let's do that. Let's put those in pi by 6s as well. And the graph goes from -2 to 4, so let's OK that. And that does look pretty much like what we've got. And we can see, since we mark these in pi by 6s, 2 squares across is where that maximum is. Now, if I now do the sine that we got, remember it's actually the same curve. So what we should see is the red curve just overlaying the blue curve. So sine 3 over 2 x and add 1. So we should see this just go over the top of the other one. So plot the blue one and the red one goes over the top. So that's an indication that we got it right.